Okay, let's keep the momentum going. Hope you had a good lunch. I notice more people have disappeared to the back of the hall. That means it's much more difficult for me to see you, I warn you. Maybe that's why you're there. But it would be helpful if you came forward because it's still a bit of a dark blur at the back. And if you have contributions, you need to put your hand up or a bit of paper so it catches my eye. But if you don't want to be seen, stay where you are. But I'm saying that because this is my personal reflection that you're moving quite significantly in the direction of addressing the core and the alerts that were put out by Amma and several of the other earlier speakers. I'm not going to repeat what I said at 9:30 this morning or 9:29 this morning, that actually your industry is still way behind. But what we've heard from the 8 presentations this morning is significant examples of significant change which is achievable at lower costs and higher effectiveness. And I think some of you will have learned and discovered stuff which you may have read about in the magazines, but you didn't really grip. And so building on what Ian and Amma want to do, and hope this will achieve, I'd like you to feel that hopefully by 3:30, before the picture, which will celebrate the fact you've been here, when you take that picture back, you'll be able to say that was a turning point for the cement industry, a turning point for us in our company, and a turning point for us understanding the new opportunities, building on what Matthias has said. This is not about a threat. This is about an opportunity and plenty of opportunities to be realistic and to see new opportunities, because I'm not going to list the kind of data that we've seen from many of the speakers today about saving energy, about saving on carbon, about minimizing so many of the costs which are at the moment creating real pressure on your margins. And I pick up again what Ricardo said. He said this morning, right at the beginning, and I've said it already once again, what is preventing you from gripping some of this stuff and going back with enthusiasm, hopefully to convince your funders, your bankers, and those who share money with you? So I leave that thought with you, because we can by the end of today feel that there's been a positive development of engagement on reducing costs and certainly reducing carbon as well, in line with everything that was said yesterday. Not just the 30% by 2030, but more and more consistently with new systems in place in a cost-effective way. I leave that thought with you as I introduced the next speakers. We're going to be talking about bringing the future cement plant into reality. Well, some of the future cement plants are already in reality, as we've heard this morning. The first contribution actually is from way out east, from Wang, who is going to speak to us first by recording. It's a 6-minute recording, so let's play the video, please.
Today, I'd like to discuss about the vision of the future cement plants and how to realize this great change. Firstly, let's look at the modern cement plant. Cement manufacturing processes consist of raw meal grinding, clinker burning, and cement preparation. Each sub-process needs to consume certain amount of electric power. The total electric power consumption is about 75 kWh per ton of cement. Fuel for cement clinker burning is mainly coal. Roughly 100 kg of cement coal is needed for 1 ton of clinker burning, with 35% of coal fed into the rotary kiln and 65% into precursor. It must be noted that the theoretical heat consumption for clinker formation is only about 58 kg of standard coal per ton of cement. The rest are wasted on kiln surface or exist with flow gases. Now we can do some calculation about the carbon emission from cement production. Unit electrical power consumption for a ton of cement is 75 kWh. The total carbon emission amount of a ton of cement production is about 535 kilograms. Okay, the future cement plant aims towards the reduction of CO2 emission and carbon neutrality. One thing we need to do is use waste heat recovery system to produce electric power. In fact, most cement plants in China are installed with a system and the power generated is about 14 kWh per ton of clinker. Another thing we can do is to use new energy resources or renewable energy, such as photovoltaic power generation and wind power generation. For cement clinker burning, we may use alternative fuels or RDF instead. Alternative fuels include agricultural straw, municipal sludge, waste tire, and solid recovered fuels. Some of them have same heat values with coal. Some of them have relatively low heat values, but can be combusted with newly developed technology. It is estimated that 10% of alternative fuel replacement of cement clinker burning can reduce CO2 emission by 26 kilograms. One important concept for cement clinker burning is to use green hydrogen in replace of coal. Green hydrogen will be produced by water electrolysis technology, and electric power can be hydropower, renewable energy such as photovoltaic power or wind power. Sometimes off-peak electricity can also be used economically. We can see that the price of off-peak power is only 1/4 of normal power, and it is estimated when the production cost of hydrogen is less than 4 times of that coal, it can be used widely for cement clinker burning, as heat values of hydrogen is 4 times of that coal. And someone may ask me why we need to transfer electric power to hydrogen for cement clinker burning. Can we use electric power to burn cement clinker directly? My answer is that the formation of clinker phases is a complicated physical and chemical reaction process, and the reaction process needs heat, conduction, radiation, and convection. The use of pure electric power cannot meet the requirement of heat supply for clinker burning. A large gas only consists of carbon dioxide and water vapor and need to be separated. Water may be used for recycling, and part of carbon dioxide will be used for CCS. Another part of carbon dioxide will be resent to the Curie system to maintain a suitable solid-gas ratio. Another important research work is to use hydrogen to react with CO2 to produce gasoline. In China, applied test using hydrogen to react with CO2 to produce gasoline has succeeded and obtained 10,000 tons of VI standard gasoline. An industrial project to produce 15,000 tons of gasoline is in process. Now, come to a conclusion and expectation. Cement is a basic building materials that will support the development of human society for a long time. The future cement plant must focus on double carbon target to reduce its CO2 emission greatly. Green electricity generated by solar energy or wind energy can be used to power the manufacturing line, and green hydrogen to combust for clinker burning. With other technologies such as concrete carbonization and CCS, the future cement plant can realize significantly lower or zero emission of CO2. Thank you for your attention.
And Dr. Wang will be joining us live. We decided to do that because there's more guarantee then that the words and the video and the slides will correspond. But I just want to repeat that last sentence. The future cement plant can realize much lower or zero emissions of CO2. And that's the challenge for this conference. Matthias, let me pick up with you from the KHD perspective. What is your assessment of whether we are talking about the future cement plant into reality or the current derivatives of plants which need to be multiplied?
Yeah, good point. I guess what we have to consider
Start again.
Yeah, that is a good point actually, because we have all those assets in place already. And I think if we assume that we now going to change all our assets and decommission plants and build new ones, I think this doesn't carry us much. We have to consider that this is a dynamic process that we're looking at for the next 25 years in order to reach net zero in 2050. So we will have to do both things. We'll have to modify existing plants with reasonable modification steps, and at some point in time we will also have to make bigger steps and maybe build new plants. But I think this is a very dynamic and diverse picture which we will be looking at.
Amma, let me just pick up because I reminded everyone this morning what you said yesterday morning. Everything is doable and proven. It's doable, done, tried and proven. What is emerging in your view of how much progress we've made in the last 30 hours to get towards understanding, as Matthias has just said, there is significant already in place, so we don't need to reinvent it?
We don't need to reinvent it. We need to synchronize how we use...
Just pull the microphone up.
Yeah, okay. We don't need to reinvent it. We need to synchronize and synergize how we use what's available. The problem is most of the innovations available are tried, done, but are not tried everywhere and are not done everywhere and are not tried and done in a consistent manner with the direction. The main part is decarbonization is a strategy, as we have elaborated on that a lot. So it has to have steps, gap analysis, and then an action plan that is across border to have an impact, a real impact.
Now, Fouad, you've got some slides in a moment, so I'm just going to pause for a moment, unless you want to come in on what I'm talking. Do you have any slides?
I do have.
Okay, but one other question to all of you. What he emphasized there about hydrogen. We talk about sustainability with solar and wind. What do you think of what he was saying there about hydrogen, the 4 times particularly?
Well, I do have some, excuse me, I do have some thoughts on it.
Are you that optimistic?
With respect to hydrogen, I'm not so optimistic for 2 reasons. First of all, hydrogen is a product of separating the most stable element on Earth. It's terribly expensive to produce hydrogen, and that doesn't really fit to the need of the cement industry to produce with low-cost fuel. Secondly, hydrogen doesn't radiate much, and in the sintering zone you need radiative energy transfer, otherwise you will not transfer the energy into the clinker. So I'm not so optimistic about that. I believe that hydrogen will have its place, but only as a facilitator to support mainly AFR-driven flames. So if we increase AFR, then the flames have a tendency to get weak, and hydrogen can tweak these flames in order to get more intensity into the flame. But hydrogen as a complete substitution fuel in the cement industry, I really don't see that.
Fouad.
Well, I think using CO2 to produce hydrogen, for example, for synthetic gases or petrols for the airline industry, this I think will come at some point. Using hydrogen as a fuel for cement plants, we don't see that really. It hasn't been tried yet. But I think we should look into always at the moment, and we should try whatever is possible. But at the moment, let's say from our point of view, Polysius, we don't see this coming.
Amma.
It's a waste of hydrogen. Hydrogen is too expensive to produce cement from it. It's a waste of hydrogen. Even if it works technically, it doesn't make sense feasibly.
Is Dr. Wang on the line at the moment? Guys? No, he's not. Yes or no? No. He's what? All right, well, can you tell me, put your hand up if he comes back online. Okay, Matthias, you've got some remarks, so why don't you do them from there or here?
From there, please.
Okay. And if you can keep it to 10 minutes, please.
Yes, I will do my very best. Hope I don't fall trap to the same thing like all the other presenters before.
Tell me more.
That is yours.
Oh,
You wanna go first?
Or you can do it.
You're the decision maker.
Or should I do it? Should I do it for
Why
you?
don't you give his presentation?
Yeah. Come on,
Should I?
you do it first.
Okay. So advancing this way.
The green button.
Sorry, Matthias.
Okay.
No problem.
Sorry.
No problem.
So I also have 10 minutes, or I have longer?
No, you got 5.
Matthias has already given half of his presentation.
Okay, so first of all, thank you to the WCA for giving me this opportunity to be part of this interesting panel regarding the future of cement plants. But before we move to the future, I would like to give you a glance of the past or of our history. So we are Thyssenkrupp Polysius, which was founded in 1859 by Mr. Gottfried Polysius. It began as a machining workshop and expanded, and then in 1898 delivered the first rotary kiln in Europe. We went through many developments. Krupp bought Polysius, then Thyssen and Krupp joined hands, so we became Thyssenkrupp Polysius. And then after many corners, today we are again Thyssenkrupp Polysius. But since we are talking today about reducing carbon and reducing costs and the plant of the future, I inserted some milestones regarding exactly this subject. So in 2018, we launched our Grey to Green campaign, which shows all our solutions for sustainable technologies. In 2021, we signed the first activated clay plant for Kammoun, and what I believe to be a milestone also for the cement industry. Beginning of this year, we signed the first contract for a pilot plant for the Polysius pure oxyfuel process. So we are full cement plant provider, delivering complete cement plants, but also all the services around it. But at the heart of it all, we consider ourselves as innovators. We have a research and development center, which is working very closely with mostly the European cement producers, keeping up with their challenges and developing the solutions for that. We talked about it a lot. 7% is the share of cement of the total CO2 emissions. I think we all agree we have to do something about it. We have the responsibility to do that. And what we did is we started this campaign, which we called Grey to Green, and we explicitly called it a journey, because we believe it has to be done incrementally, step by step, as we witnessed it in the European market, who had their time to develop solutions, and we accompanied them with that. So I don't want to go through the pain points of cement plants. We talked about it a lot. We all know them. Let me jump to the core of the subject. How does the plant of the future look like? According to us, Polysius, we think the plant of the future will have efficient use of raw materials. It will use its energy optimally, at best use 100% of alternative fuels, and have also use of SCMs. It will have largely automated processes, maybe with artificial intelligence, and CO2 capture units. But I would like to divide here, let's say, the path to go to the cement of the future in two. Nick, you just asked this question. I think we have to consider two ways. For existing plants, there's a way, and how future greenfield plants will look like, according to us. So for existing plants, this was also said a few times now, low-hanging fruits, upgrades to state-of-the-art equipment can be done in order to improve energy, heat consumption, equipment for reaching high thermal substitution rates with alternative fuels, better resource management with digitalization, and also improvement of quality control, because the quality with maybe composite cement will be much important to control and observe. And activated clays, etc., additives in cement. And from our side, from Polysius, we are glad to have all these solutions. So in case of upgrades to, let's say, improve or upgrade calciners, improve the power consumption of grinding plants, of crushing plants, we have all these possibilities, all the technology for that. We have a very interesting product for burning of alternative fuels. I will talk about it a bit more in detail in a moment. We have laboratory systems, control systems. We are currently working on a pilot a project with artificial intelligence with promising results. Until now, we have in our portfolio waste heat recovery, and like I just said before, Polysius activated clay. We have also the possibility to test clay in our laboratories to make sure whether this clay is good enough in order to be produced and used for cement. But I think when we talk about, let's say, reducing the carbon footprint for the region, what I see today is that the quickest win could be achieved with fuel substitution. We talked about low-hanging fruits, yeah? And I believe sincerely that any solution needs to have a good business case, or at least to bring value to the plant. And what we have as a solution here is the pre-pole step combustor. So a few advantages. It can be connected to the pre-calciner. It uses the heat generated by the process, and the main advantage is that it allows the alternative fuel to burn completely with a long residence time. And we actually have two possibilities. So for customers who want to go for a high TSR rate, so 80% at the calciner, they can go for the large pre-pole step combustor, for example. And the advantages of this SC system is that it allows the use of low quality alternative fuels. So Mr. Lechtenberg talked this morning about first eliminating the particles which can be recycled and using the rest. And the rest is usually low quality. So this system allows its use. And we can use in it actually 3D components with a size of 300 by 300 millimeters. So it's a very flexible system. But if customers don't have a lot of RDF available, then they can go for the little brother of the pre-pole SC, the SCS, the small version, where they could reach up to 30% TSRs. But there, the RDF or the alternative fuel cannot be of, let's say, large sizes or very, very coarse. And this technology is proven. It has been, so here there's something cut. We have 11 installed pre-pole systems worldwide, not only one, but 11, and 5 systems currently in execution. And these 5 systems have been actually ordered in the past 1.5 years. So at the moment, we have really a lot of inquiries. We are flooded with inquiries regarding alternative fuels. I think it's obvious the time is pressing. It brings, at the moment, with the high coal or fossil fuel prices, it has a very good return on investment. So it makes a lot of sense to go for it now. And that's why I think this is a solution which has to be tackled right now. So now moving on to the future and how we Polysius see the future of cement plants. So for this, we have the Polysius pure oxyfuel process. So basically, it has been said a few times now, the highest carbon avoidance ratio comes with carbon capture. So with this, with CCUs, we can capture the highest amount of CO2. It's obvious, but it was said a few times now, this has the highest cost. But still, if we look at it today, Europe is considering CCUs. So I'd like to explain a little bit why this has happened. In April 2020, Heidelberg Cement showed the slide where they said that, I hope it is clear, where they said that the CCUs will be feasible when the price of CO2 certificates will reach around 60 euros per ton. But actually, in May of this year, the price of ton CO2 reached 88 euros per ton. So suddenly, CCUs became very feasible. And the big players in Europe started pushing for it a lot more. This is again a chart showing this price, and it's expected to be higher. I think it went down a bit now to around 73, 75, but it is still expected to increase. So in parallel, we have been working on oxyfuel carbon capture. So just very quickly, because I'm not the specialist here and time is limited, in a conventional process, you input raw meal, fuel, air into the system, and you have an output, of course, the clinker, and 30% of the flue gas is made out of CO2. So if you look down to the oxyfuel second generation process, the idea here is to inject pure oxygen in the system, and what you get in an airtight system, I have to say, in an airtight bioprocessing system, and what you get is around 90% of CO2 in the flue gas. And then when you capture this CO2, the carbon capture is much more efficient to capture out of 100%, 90% rather than 30% of 100%. So as I said, we had developed this concept, and the latest one is the second generation. Even according to our design, the preheater will be smaller than the, let's say, the classical preheater. But of course, because the system has to be airtight, you can imagine it's much more high-tech, so it's much more expensive. But basically, the oxygen supply or the oxygen will be injected at the cooler. So, yes, so, yes. So practically, what we are saying here that the cement plant will need a source of oxygen and will deliver the CO2 to the carbon capture, and the CO2 needs to be used, of course. So our vision of the cement plant of the future, that it will be practically delivering CO2 to following industry, such as methanol plants, for example, or other chemical industries. Although this looks, let's say, as a future which is far away, but it's actually reality now. Like I said, we signed this year the first contract for oxyfuel, pure oxyfuel, with a group of companies or joint venture called CI4C, made out of Schwenk, Heidelberg Cement, Buzzi Unicem, and Vicat. And it should go into operation in 2 years' time, in 2024. And as you can see, there's CO2 carbon capture. And this is not the only project we are working on. We are currently also involved in a project in the north of Germany. As you can see here again, the cement plant is, let's say, a part of an industrial park, receiving oxygen from an electrolysis plant, delivering CO2 to methanol synthesis. And this is what I said before, that this is one of the possibilities that the methanol will be used to produce synthetic gas. At least this is the plan here in this project for use in airlines. And that's it from my side. Thank you very much. Thank you.
Thanks very much. Give it to Matthias. Let's move on swiftly, Matthias.
All right.
To see what you're adding to what Fouad has said about the plant of the future.
All right, the plant of the future. Let's begin with this title. What I want you to understand is it's not a binary thing, one decision thing. There is no such thing as the plant of the future. We're looking at a transition process. And the future, in that sense, starts today. And it will continue for the next decades until we finally reach net zero in 2050. So don't expect something to pop out of a box giving you a solution. You just have to apply it, and then you have the plant of the future. It's an emerging thing. It's an evolutionary thing. And there are steps on our way to the future. And in that respect, I'd like to maybe add some perspective to a topic, to a substance matter, which we've been touching several times, Nick. You've been talking about optimism and pessimism, and we've said, okay, let's be realistic. I think I can imagine what's in all of your heads now is a big deal of uncertainty, because we feel this wave coming to us, and we feel that pressure to decarbonize, and we look at the cost, and all this pressure is coming up to us. And what is remaining in us today is a big deal of uncertainty. And in that sense, I'd like to add another dimension to this pessimism, optimism thing. I'd like to add the dimension of hope to it. And by that, I will be tweaking the words of a German philosopher only a little bit by saying, you know, hope is the activating alternative to the fatalistic pessimism and the naive optimism. So think about it. Maybe that can give us a little bit activation on our way into the future. With all this uncertainty ongoing, I thought I'd like to structure a little bit the field of technological possibilities which we are looking at. And due to the shortness of time and the inability to possibly read what is in these boxes, let me just explain to you. This is the attempt to give a structure to the technological field that we're talking about. We talk about several different new technologies or emerging technologies or modified technologies in the range of our cement industry. Grinding technologies, pyroprocess technologies, novel concepts, modified concepts. We talk about the whole field of CCUS. We talk about cement recipes and the whole range of technological possibilities. It's a huge landscape of technical possibilities. And I thought it would be good to also relate those to the roadmap of the International Energy Agency, which we saw earlier today already, and the color code refers to those levers which are given in that roadmap. So green is anything dealing with thermal energy efficiency, fuel switching in blue, reduction of clinker to cement ratio, and innovative technologies, including carbon capture in that orange coloring. So you see, even though this doesn't claim to be complete, it's a huge range of technologies that are possibly coming up. Some of them are still developing, some of them are not even on the list. It's a huge field. So those were the technological aspects. And there are also many non-technological aspects. We've been touching on those already several times during this conference, but I thought I'd summarize some of them here as well in the slide. First of all, for me, a very big issue to be solved is norms and standards. Quality standards for cementitious binders in different regions. And I'd like to refer to something that A.Nader has also said, I think, in the previous sessions. There's a lot of possibility in learning from what others have done in other regions. There is no reason why in some region, some recipe for some composite cement should be viable and in the other not. We cannot afford this luxury to, keep on thinking in our own comfort box if we want to meet the challenges of the future. The second thing that is very important also, and I'm going to give more details in the following, the logistical situation of a plant. And I know that as an OEM equipment supplier, we've been supplying cement plants to the same flow sheet, to the same scope of technology for decades. 5-stage, 6-stage preheater, calciner, rotary kiln, cooler. Yeah? That was the clinker plant. In the future, when we are going to integrate other technologies downstream or upstream, it's going to look different. And it will be ruled by the question, how is that cement plant connected to certain logistical site conditions? Proximity to certain markets and logistical systems, cross-industrial connectivity for synergetic combination, and availability of certain feedstock, very important. Third thing is the legal and political framework. It's still totally unharmonized. It's not so easy to get certain feedstock and certain materials shipped across the borders. And of course, we all know about the carbon tax issues that need to be solved, tax, political, and environmental, business, regulatory aspects need to be harmonized. Non-technical stuff, but very important. And I repeat what I said earlier in this conference, I think these are the real obstacles. Technology is there. These are the real obstacles. All right, which technologies will be feasible when? As I said before, this is a dynamic situation. It's going to develop over the next decades. And I try to put those technologies on this diagram that is opened by technical maturity on the x-axis and cost impact on the y-axis. And we're going to look at alternative fuels. I'm sorry, you will not be able to read that. I'm sorry for the color mismatch. So that bubble is called AF, alternative fuels. It's cost neutral because it can even save you costs. And that is one thing you can start doing right away. Think about alternative fuels. It can reduce your capex and it can reduce your CO2 emissions, but it doesn't come for free. You'll have to do something about it. But it can have a very big impact. The next one is SCM, cementitious materials from alternative sources, also can have a huge impact. We've been talking about that in the cement recipe. That one is called RTO, which stands for Runtime Optimizers. That is summarizing everything with enhanced and possibly AI-driven operation optimization systems. Then we have, I have to look here, calcined clay as a special form of SCM, which is special in that respect because it has the potential to really substitute feedstock resource like limestone on bigger scale. We would be mining the kaolinite and the clay and process it so that this can really be a technology for itself, even though it produces an SCM in the end. Then we have anything that I've mentioned here as alternative raw materials. You see the bubble is a little bit smaller, so the potential isn't that big. We will, by producing clinker, heavily rely on limestone, obviously, if not substituted by calcined clay or other industrial wastes. Then we have this big bubble of post-combustion CCUS. So amine scrubbing, and these kind of things that are available still already today. It's available, but it's very costly. So it's very mature, but very expensive. And as was given by Fouad earlier, oxyfuel, CCUS, oxyfuel concentrates CO2, so the capture process is less expensive. That is in the making, huge potential. We're gonna have to use it once we want to achieve net zero back in 2000, from 2030 onwards, I have to say, maybe even earlier. Then we have some other technologies like indirect calcination. You are all informed about this Calyx, lilac system of indirect firing and direct extraction of a pure CO2 strand. And there is also something called calcium looping, and there are possibly other technologies coming up as we proceed along the way. Naming only those, most importantly, I tried to group and cluster them. And there's the first group given here, which is readily available today, and you can start tomorrow with it. The second one is also available today. You can start tomorrow with it, but it's very costly. And the third one is developing technologies which you would wait and pilot first, but by the end of 2030, you would have to make your pilot installations and your technology developments together with the OEMs and every stakeholder in the industry to have the feasibility check done by 2030. All right, I'm saving some time. So feasible technologies ready for implementation now. This is now the extract of the previous analysis. Runtime optimizers, expert systems, intelligent operation systems, whatever you call it. Runtime optimizers are increasing the efficiency of cement production with machine learning and process knowledge. It's very important to also include process knowledge into it. I come to the explanation why later on. And they are increasing the availability and synergies with IIoT. So anything that is Industry 4.0 connection, data communication among assets, and data integration. There's a huge potential that can be raised already today. Alternative fuels, biogenic fuels. Alternative fuels, and especially biogenic alternative fuels, can considerably reduce OPEX and CO2 emissions at the same time. Although I'm not encouraging you to just go ahead and throw that stuff into your kiln, it's not so easy. There are some things connected to it which can jeopardize the stability of your kiln production line. Most of the cases, some adaptation of your plant equipment is necessary. Clinker substitution, calcined clay. I think we've been talking a lot about that. I can save some time here. And finally, the outlook into maybe the midterm perspective is oxyfuel kiln conversions. And I believe that actually oxyfuel is a technology that is good for converting existing assets into oxyfuel plants so that you don't have to build a new plant for it. And with the, I don't know how many, 5,000 cement kilns on this world, by 2050, they all have to be decarbonized. So we talk about a massive population of assets, which we're not going to decommission. All right, let me just briefly tell you what we can offer to you. I put all that together in smart factory technologies, IIoT, RTO solutions, so Industrial Internet of Things, runtime optimizers. They all build on the same method. We collect data. We handle these data either in so-called edge on-premise technologies or cloud technologies. They come with pros and cons, can be figured out according to your preferences. What we basically try to install is a digital twin technology. So what we have in mind in the product which we've developed under the name KHD Pro Max is a digital twin running online parallel to your real plant, being fed with the data from the real world, running a model comprising, well, everybody says artificial intelligence, but there is no artificial intelligence. I'd rather speak about machine learning. Anyway, so this system analyzes automatically the state of your production and can derive analysis and directive in order to optimize your production process anytime. And also facilitates synergetic data utilization, like integration into SAP systems and ERP systems and all that. And what it also does through the interface to the cloud is to have integrated services by your equipment supplier that help you keeping up the performance, making sure your plant is always running under best can be conditions, because automation supports that, and experts looking at that, the best experts looking at that. And if something happens and some anomaly pops up, there will be an automated system to get noticed and to get intervention by the best knowing expert, either from within your group or from KHD or other equipment suppliers. So remote service is something that is also getting us closer together, equipment supplier and plant operators. And of course, as I said, all that will be driven by a combination of machine learning and process knowledge. Now, allow me 2 sentences on machine learning. Machine learning, so artificial intelligence doesn't exist today. I'm not sure whether Sharif or somebody will contradict, but what does exist is machine learning. And machine learning is an automated technology that is good at learning from what it has been taught with. So that is very efficient. We know all that from toothbrush, face recognition and everything, pattern recognition. What you've seen, you understand. That is machine learning. However, in cement plants, we suffer from disruptions, from things that don't go as they were planned. So that's why most of the machine learning-based RTO systems have a tendency to drift apart after some time, and then they're switched off. That has happened to a lot of machine learning, artificial intelligence-driven RTOs. So that's why it is very important to pair this machine learning together with process knowledge, to tell the system, well, you know, you are adapting to a changed condition. That's right, you should always represent the situation as it is today. But, you know, I don't like your drifting. You should be going there. Somebody has to tell them, no, get back to that one. That is very important. All right, next on the list, AFR. I'm speeding up to leave some time for discussion. The picture you see here is the picture of what we call the pyrorotor. It's the rotary, small rotary kiln, which allows up to 95% or virtually 100% thermal substitution rate. And the specialty is you don't need fine processed material for it. You can feed things of this size into it. So that really cuts down your preparation costs. Also, we have a whole range of other technologies, modular, to satisfy each and any substitution rate target and material feed you'd like to put into your pyro process. Calcined clay. We've also been talking about that, and believe it or not, I recently found out that KHD had the first patent filed back in 1982 on a flash calciner-based clay calciner technology, looking actually like what we're proposing and offering and installing today. So that is a system. We prefer the flash calciner against the rotary kiln for a very simple reason. The quality of the calcined clay depends on the exposure to heat, which is defined by the retention time and the temperature. And if you overrun the exposure to heat, then this calcined clay forms a mineral called mullite, and that is no longer hydraulic active. You don't want to do that. So you restrict the temperature to 800, 850. You don't want to overrun this temperature, and you restrict also the retention time to the required retention time. Now, in a rotary bed, in a kiln, it's very hard to control the temperature and the retention time. So flash calciner definitely is the process-wise the better decision to go. We've developed a patented two-step process for, say, oxygen and color control. And all this is mature technology. This is ready to be installed. You can go away, you go ahead right away. And finally, coming to an end, this is a flow sheet of an oxy-fuel plant. Again, I'd like to give one final remark towards oxy-fuel. We might not be so far away from oxy-fuel. I believe that with the oxy-fuel process, it's possible to convert existing kiln lines to oxy-fuel process. You add a recirculation line, you do something about your ceilings, you do some here and there, but it is possible. So you don't have to build necessarily new plants for it. What is also very important, though, and that may be my final remark, when we talk about CCUS, and I've fallen to that trap also for more than 12 years that I'm dealing with oxy-fuel now. We're looking at those technologies. How can we capture CO2? Now again, this is not the problem. The problem is what do you do with it afterwards? If you don't happen to be connected to a pipeline, what do you do with these tons of CO2? So we have to think this process from the back. So we have to first start thinking, what do we do with the CO2? Do we have a pipeline? Do we have barges or trucks or whatever? Can we bring it to a feed-in point of a pipeline? Or do we feed it into a chemical factory or something like that? What do we do with it? Very important. And also, this is very important because it defines the quality of the CO2 you have to isolate. And that can be very costly to produce high-quality CO2 unnecessarily. So start thinking, what do I do with my carbon? The chemical industry is eagerly looking for carbon because they have to defossilize. What we call decarbonize, they call defossilize. So they need carbon, but in what form and how? And if you solve that, putting the technology to capture it, I wouldn't say it's easy, but it's doable. So that was it from my side. Thank you very much.
Thank you. What I'm proposing is, because we're going to ask Ian to come up here shortly, to move forward on net zero. But a reminder that this is not about a conclusion. This is about some kind of takeoff and takeaway. Does anyone want to raise anything with Fouad? Please, at the back. Microphone over there, please. Anyone else want to, particularly for Fouad, because what I'd like to do is merge the two sessions together very smartly to produce that takeaway.
Mustafa Rakhawi from A3&Co. I want to ask about the oxy-fuel technology. I know other carbon capture and uses technology need special requirement of energy increase. Is the oxy-fuel need energy uptake to have the capture of the carbon dioxide or not? This is one question. The other question is, there is, for carbon usage, the flow sheet you show us for the Germany plant, the industrial city in Germany, is capturing the carbon and then using it in other applications. And in that case, companies will not benefit from the credit. That's what I understand also.
Thank you. Fouad.
Thank you. I'll start with the second question. So the CO2 will act practically as a product. And it's still not clear. This is still for the pilot project we have. It's still not clear how it will be exactly done. But either the CO2 will be practically sold to the, let's say, next chemical plant, or the carbon credits move over to the next plant. Yeah. regarding your first question, I need to understand better what do you mean with energy increase?
The carbon capture plant requirements is to uptake the energy requirements of the cement plant. For example, if I'm working now in Lilac technology, for example, if I'm working with 780 kilocalories, I need to increase my energy usage first to be able to capture the carbon. If my understanding, same goes, I think, for oxy-fuel.
I mean, obviously you have for the carbon capture plant, you need an energy, and there's a higher energy consumption than the classical line, for sure. But according to our calculations, still this energy consumption, this additional one you have, will not be that much to, let's say, to be more than what you are capturing and using from the CO2.
Anyone else?
Can
Please,
I follow?
microphone
Can I follow?
there and there. Now, Amo, you've got a presentation as well. Do you want it for this session or the next session? Or between the two?
It's between the two.
All right, will you be the transition?
Yeah.
Please, microphones here. Can we move the microphones quickly, please?
Sorry, can I follow something? I know it is almost double the energy in other technologies. I don't know in carbon capture, in oxy-fuel, it will be how much?
To be honest, I don't have a number, I don't have a figure to give to you exactly. I can ask and maybe give it to you later.
And there as well, please. Who's got the microphone next? Here.
Thank you, Fouad, for your presentation. This is Ali Rushdi from A³. My question to you is, what is the efficiency of the carbon capture unit when using the oxy-fuel? You say the gas flow containing 90% CO2. How much from this 90% I can catch? The second question, you mentioned that the airtight is a must in using the oxy-fuel. Up to how level the airtight should be there? As we know, the traditional cement plant, the false air in preheater, we cannot go beyond 5%, and we cannot maintain this. This is my question. Thank you.
So regarding the question,
Fouad for the moment.
So regarding the efficiency, so the carbon capture plant will capture approximately 99% of the CO2 in the flue gas. And regarding the sealing, I know it's inimaginable to have, an airtight kiln line. So it's a complete new technology where you have seals, of course, working under, so high-efficient seals working under high temperatures. But this is possible. We have the design already, and the plant is being implemented. So I can assure you it's possible, but we cannot, we don't have, let's say, the possibility to say too much about it because of confidentiality reasons.
You're among friends here, so you can talk confidentially.
Well, I think I was very friendly.
Matthias, quickly.
Yeah, I can add something, and we can all be friendly because, as a matter of fact, the efficiency and the capture rate and all this kind of stuff is depending very much on what technology you use. You can use membranes, you can use pressure swing, temperature swing, you can use a whole lot of technology just for the capture as such. And all these technologies come with different efficiencies, different sensitivities to, concentrations of CO2. Like, for example, in pressure swing, you can go down to 70% of CO2 only. So that, minimizes the potential threat of false air intrusion. The real answer to your question is need to know what you're going to do with the CO2. That defines the quality you need to have. That defines the technology of capture you want to employ, and that defines the necessity to suppress false air intrusion and all this kind of stuff. So this way backwards, you have to figure that out. And you can reach any kind of capture rates and any kind of efficiency.
Anne.
Yes.
Wait a minute, I'll go to Anne first.
Okay. Just coming back also, I think we have to take the helicopter view of the CCUS, which means that we need to look at the technical problem after having looked at what will be or exit of all this CO2, which means that the industry and the CEO and the sustainability officers need to be now in the discussion with the other sectors in one country, especially the energy and oil and the oil sector, because they are beginning the discussion now, which means that the cement industry has to jump now into the discussion in every country, otherwise they will be left over. And discussion between universities and the oil sector are now going on. So
is that a comment, more a comment than a question?
It's more a comment, is that we need to act now, because if it's commercial available in 2030, we need to anticipate and to look at the transport at the technical feasibility between now and 2030, which means that we nearly don't have only 7 years.
No time left.
That was made very clear, I think, in the comments yesterday morning, right at the beginning. Do you mind if I go to...
Yeah. Felix Barknecht from SICK. Thank you, both of you, for the highly interesting presentations. You both introduced two technologies that can be used with very coarse alternative fuels, the pyrorotor and the step combustor. Now, I've seen the pictures of materials that are going, for example, into the step combustor. But this morning we discussed that cement producers actually need to define the biogenic content of this alternative fuel. So from a practical point of view, how can someone define the biogenic content of such coarse and inhomogeneous alternative fuels which you are using in your technologies? From a practical point of view, I don't think that's even possible.
Keep going.
Shouldn't we answer?
I'll answer that question.
So both of you,
please.
So if I may start, Matthias.
Please.
I think we should be very clear. We cannot say we can throw anything in this machine. Yeah? Of course, this is a fuel in the end. It has to have the right quality. And it's not only about biogenic content, but about chlorine content, about moisture. Moisture is very important. So it's very important before to make sure you know which fuel you are getting, because also in the end the goal is to use this fuel for a very long time. So you need also to make sure of the quantity with the same quality. So it's really an individual thing, I have to say. And when we say it doesn't need a lot of preparation, then we don't mean it doesn't need any preparation, of course. It's very important to monitor the quality of the fuel as well as with any other fuel. But our system allows the plant to be more flexible and not necessarily be dependent on very small RDF.
Right at the back.
Maybe a short addition?
I think...
Go ahead.
Okay, yeah. Maybe a short addition to it, because you've been asking both of us also. Well, first of all, the determination of the biogenic content is something that the cement producer has to be doing. We will be very supportive to find an instrumental solution for that. But the content of biogenic parts in that RDF or that waste stream will become increasingly more important if we use AFR as a method to reduce CO2. And exactly for that reason, we've chosen, for example, to design this reactor as a rotating drum, because we need retention time and we need robustness against sticky slags. And if you look at, for example, wood, pieces of wood, you enjoy putting pieces of wood in your fireplace in the evening because you don't have to put new pieces in there after only 4 hours, maybe. But this piece of wood takes exactly the same 4 hours, if it's big enough, if you want to burn it in a cement kiln. So you need retention time. Absolutely vital retention time, and biogenic fuels have a tendency also to emit sticky slags. So you want to have a reactor that is robust, creating new surface all the time, and allows sufficient retention time.
Thank you.
One question. Yeah, this is Srinivas from JSW Cement. One question regarding the pyrorotor. You said that 95% alternative fuel we can consume in it. So how much extra heat we have to spend on it to run that pyrorotor? For example, say my plant is running at 700 kilocals. So how much more energy is required to run with the pyrorotor?
I'm not sure I got the point right. How much?
How much energy, more energy we have to consume with 95% AFR consumption in pyrorotor?
That can't hardly be answered, you know, not recognizable because it's energy you would put into the calciner anyhow.
Okay.
Could you pass the microphone back, way behind you? Do you have a microphone?
Yeah, I do.
You do have a microphone,
Yeah,
okay.
I have one. Thank you. Just comment, I wanted to agree with Matthias on two things. One is that I was going to comment on his comment on AI. And the other part is that I agree that, you know, so a very important point you made on that traditional machine learning in AI cannot deal with situations that it has not seen before, circumstances it has not seen. So in many cases, it's not suitable to deal with, you know, the kind of unexpected things that happened in a cement operation. But you know, the kind of the key where I would disagree is that there are sub-branches of artificial intelligence, like reinforcement learning, for example. And I would urge everyone, if you Google search for something called DeepMind, which is a kind of Google's main AI subsidiary, and protein folding, and look at the approach of reinforcement learning and the way that you can use that to actually. Protein folding is not reinforcement learning, but generally look at, search for DeepMind and reinforcement learning, and look at different approaches of AI that are able to learn, able to deal with situations that are completely unexpected, as well as much more complex situations that require many changes in parameters and do not require that prior knowledge, that prior ability to have seen things, and to overcome that problem with machine learning. That's all.
Short reply, just short. Thanks for making these statements. I think you know what you have to know about machine learning is it is an excellent and established and workable solution to train something on something that has been recognized. A cement plant is constantly drifting, so that's why we apply two artificial neural nets who are constantly training and being checked, and if the one is drifting, we activate the other one and then hedge everything within process given limitations. Just a little additional comment.
I need guidance here. Ian, we're overrunning significantly, but we've got a dialogue going, we've got a conversation going. We've still got to talk about net zero, we've still got to have a picture. I'm tempted to keep this going for another few minutes. Well, Emma's going to do the transition into the next.
Yes, transition is getting too long as well.
But the transition into net zero. The thing is, there are a lot of contributions from here as well. I'm looking for guidance here on timing. I think that's...
No.
I have a small comment only on Sharif's statement and then Matthias' statement about machine learning. We went through a machine learning project before. Sorry, Sharif. I think from my point of view and practical learning that it will require some process knowledge, at least in the data analysis, with the data analysis at the first stage. That's all. And for machine learning, of course, the data you provide to the machine is how the machine will react after that, and it is, of course, a very good solution and approved. Thank you.
There was one question over here. Oh, no, over here. I can hear you.
No, we need to have the microphone. Do you want to answer that question?
Yeah, that was no question. It was a statement.
Maybe I
can repeat your question.
No, we need a microphone, please, because we've got to have people at the back hearing. And also the gentleman there. Go ahead.
It's about machine learning. You have to teach the machine the good approach that the machine should follow first. So knowing the good performance of the machine, you have to maintain it first, isn't it?
Yeah, if it would be so easy, then we wouldn't need artificial neural nets because we can define upfront what is the good way of operation. The problem comes up that there's always disturbance. And the reality of the situation of the operation of the plant always changes. You know, there is some feeder giving more or less heat content to it, or some rotation, some sticky, whatever. You know, operating a cement plant is a constant disturbance, I always say. And you just have to know where the disturbance comes and how big it is.
I like the term constant disturbance.
I'm sorry about that. I think it's real.
I'd like to comment on that. I think I fully understand that it's difficult to trust a machine, yeah, especially when we, cement producers acquired this knowledge with after so many years. But this is exactly, I think, the point of machine learning. And the nice thing is we can let such a neural network learn, yeah, and let it try and see how the results are, and then decide whether to use it or not. But I think the difficulty with machine learning or artificial intelligence is that we don't know how this complex algorithm works. We cannot match it. So I think it's a difficult thing to let go, the plan definitely. But from my point of view, we should be open. We can try it, see if it works. If it works,
this is why it only works on optimized and reliable plants. So you need to do optimization and reliability first, and then you add whatever artificial intelligence and digital maturity on top of it. If you just went to digital maturity, you will keep running behind. The only way is to optimize, put reliability on top, achieve KPIs clear, see it happening, and then add artificial intelligence. If you try to do it first, it will never work. You will keep running behind.
All right. I warn you, time is now getting really tight, and I'm trying to balance an awful lot here. But let me go to this comment here. And Ricardo, I'm going to ask you if I can come to you, given what I reminded everyone what you said about people preventing changes of thinking. And I also want to come to you, Matthias, because then we need to move into the next session when you're going to transition hammer, and we're going to try and finish by 4 o'clock before the workshops. So please, your thought.
I just want to ask about the carbon dioxide capturing plant, okay, by the new technology, the area of execution, okay, of the plant, is it too much large, or how much in meter square? Another question for the purity, you told that it's 99% capturing of the carbon dioxide. How much is the purity? And can it be used in the food industry or not?
Thank you. Pass it back to Ricardo, can you? Behind you.
So actually the space required for such a plant is the same as a classical pyroline, except of course you have to add the CCU. So it's not really taking more space than a classical plant. Regarding the purity, so Matthias just said it before. Also, there are different possibilities to capture the CO2. There are different technologies, and the technology depends on how you will use it later. I think he said that already. But in what I showed is this particular case, and there it's 99% purity. I don't know if it can be used in the food industry To be honest, it's beyond my knowledge how it can be used.
Surely not. 99%, surely not. You don't want to have 99% pure carbon dioxide in your drink, not knowing what the residual cement percent is.
Matthias and Ricardo, are we underscoring that there's a mood here of realizing new opportunities from the granular questions we've been getting?
Good question. I wish I would know the answer.
We'll have a guess.
I guess, yes, we have been able to initiate some thinking of, not necessarily urgency, but possibilities. Because we've been highlighting a lot of options that can be done right away, and they will even synergize positive effects on other fields. Let me come back to the operational excellence session. If you reduce your false air entry into the preheater, you will immediately take a benefit from it, both in energy consumption, production, and CO2 emission. If you start looking for alternative fuels, you will immediately have benefit on your cost bill on fuels. I'm very hopeful, to come back to my comment, I'm hopeful that we were able to initiate some triggering here.
Let me just do a quick hand check, totally unscientific. Who is going to go away from this after 36 hours thinking, I've learned a lot, I've heard a lot, my eyes have been opened to things which are happening in the cement business, which I wasn't fully aware of? Hands up, yes. It's a bit unfair of me to ask, has anyone sat here for the last 36 hours and learned nothing? But would anyone like to put their hand up? We have a total majority. The reporting can be there is total unanimity that everyone has learned something from this, which comes to Ricardo. I mean, you said when we started talking this morning that you felt that there was a degree of preventing going on, preventing eyes being opened, preventing thoughts being enriched. What's your thought at the moment?
Well, I think we are getting some traction there, particularly from the questions we are getting. I sort of start feeling we are getting an understanding of what are the concerns, what are the worries,
and the
cement
opportunities.
Producers, and the opportunities, of course. Maybe as we still have a chance to have the panelists here, I'm going to ask them a question.
They're not going to stay very long.
Okay, so a very quick question. I mean, I'm sure you're meeting with cement producers.
But I want to be very clear,
yeah.
Ricardo. You feel that already in the last 6 hours since this morning, there is a movement of wanting to understand much more. I don't want to put words in your mouth, but given what you said to me and what you reported literally at the first minutes this morning, have we moved? Are we moving the mountain?
Well, I can only answer for myself. Yes, that's the feeling I'm getting.
That's good. You can ask your question now.
Thank you. Do you mean otherwise I would not be able to? Now, I'm sure you're meeting with cement producers almost on a daily basis. So aside from, of course, financial, CapEx, justification, concerns, or questions or doubts, what is the typical questions, the concerns you get from them? Is it like these technologies are not mature enough, is like of risk adversity? Is there some very specific concerns you've been asked over and over again that perhaps you're already trying to address?
Fouad.
Okay. Good question. There are always concerns and always, let's say, producers are always looking for solutions. And that's why, in my opinion, there are always possibilities to improve on all the scale in a plant. And from my personal experience, the producers are always looking to get better. But most concerns lately were how to reach quickly, to name one important, which I am facing a lot at the moment. How can I reach quickly a high level of alternative fuels, but not having any infrastructure for the waste coming to my plant? And this is something I see in many countries with many customers, and they want to do something, they want to move forward, But when it comes to getting the waste, then they cannot really move forward because it's in the hand of the government, of the authorities. And what I see, this is very unfortunate that the authorities are not moving as quickly, as swiftly as they should on this issue, because it can solve two problems in one. On one side, let's say, help many societies get rid of their waste. On the other hand, reduce the cost for a cement plant. But there's always this hickhack of who does the investment in the preparation. This is something I face everywhere. Many plants have this concern. So
thank you.
Yeah.
All right. Now, what I'm going to do is I'm going to ask you to do a hot switch with Ian. Ian, do you want to come and join us up on the platform? So thank you very much indeed for your comments. Matthias, you're staying with us, I think.
Thank you, everyone.
And Amr is going to give some transitional thoughts. And Ian, while you were out, everyone put up their hand when I asked if they had all learned something and going away with better understanding of the options. No one said they had learned nothing. You're going to sit on this platform, I think.
Mike.
Oh, okay. Yeah. Amr, we've got about 20 minutes, so the floor is yours. The machine, the clicker is here.
No, it's not here.
Is it not there?
No. Oh, yeah.
Sorry.
No problem. So, just a comment on the earlier session before I go to that, which is a continuation to our aim, me and Ian, of making this panel was to bring the biggest producers of manufacturers of equipment in one place, talking about the technologies that is possible for the cement industry. And we got KHD and Policius, and we hoped for FLS, but due to some reasons we couldn't. So the idea is what has been shown between KHD and Policius is, first of all, there are similarities in the line and direction. Policius has their gray to green, and KHD had their own line of clubbing the closer technology, and FLS, I'll talk on their behalf until they are here. They have their zero mission, and it's all in line, in direction of technology. So for producers, there is no excuse. All the players have their technology ready.
FIF is also here. FIF is also here.
Yes,
and
and
presented.
FIFs are also here. I'm talking about full integrated plants, and we have showcased in the morning also so many solutions that are bits and pieces complementary to the cement plant, and they all result in the same thing. They are all in line with the roadmaps that we are talking about. You could see the clubbing that KHD has made is exactly in line with what we call the low-hanging fruits, and it's exactly in line with doing what's easy first and what's possible first. If you looked at Policius or Thyssenkrupp, I'm still used to call them Policius, but Thyssenkrupp approach, it's exactly the same until we reached the oxy-fuel part, and we started having questions of how and what, and so till we answer these questions of how and what, and we have it clear, as you didn't see anybody asking about very specific small questions when it came to alternative fuel or SCM, because generally speaking, it's known. We just need a push to do it. And just last comment on the alternative fuel in countries that doesn't have waste management. I've seen that. I've worked on alternative fuels to the limit of the 30%, which we hope to reach first, then discuss 60 and 100. In countries like Pakistan and Uganda, which doesn't have any waste management system whatsoever. But because of the necessity, it was absolutely done. Dirk, if he's still here, yes, he has started the alternative fuel part in Pakistan in 2005. You can ask him about the state of the country when he was there and the level of corruption. Someone was talking about that big agglomerates couldn't make contracts with municipality because this is all excuses. There are ways around it. And it's doable. And I'm talking about 2005. I'm talking about 17 years ago. This is doable. And it was doable in countries like, if it's done in Pakistan, if it's done in Uganda, if it's done in Zambia because of the necessity, it can be done in Middle East and North Africa, either by a push by the government, which is going to be a mandate, and it's coming, or proactively by the cement plants to start really doing it. So this is exactly the essence of the last paper. I will just, from a future cement plant, and I just want to underline one thing, that the future cement plant is not a hypothesis. There is an actual scientific definition of future cement plant. It's commonality, and it's approved, and it's actually registered in many cases. If you looked it up, there is a future power plant, there is a future cement plant, and they were put on the World Bank definitions to be a reference on how to design it properly, which is in line with climate and other urgent issues. So I'm putting here my own definition of a future cement plant, and my view is, may I stand, Nick, please? So my view is digitization and sustainability trends to earn a competitive advantage and build resilience. That's simply what a cement plant needs to do. We need to be resilient, we need to be digital, and to maintain the competitive. How we do that is, as we could see, available very good on all supplier levels and with many solutions. The point is we do it. And the way I see it is there are two sides of the story, rightfully, to Nick's question, and it was asked too many times, and it was also in KHD presentation on before and within, greenfield and brownfield sites. So on the design phase, if we are doing a greenfield, and I'm talking to people who are actually doing new lines, and we did not include the dimension of green into it, the retrofit is much more expensive. If we don't do it while doing the greenfield, it's going to be very expensive later on. We will be in the case of the blockage or the pessimist or the defensiveness that we were discussing over the past 36 hours. So we have to do it while doing the design. And there is a very simple way to do that, that is in line with the designs that's happening now. And the other one is during operational phase, where we have seen during the whole day solutions that can retrofit, that can complement the existing operation and reach the green direction and the carbon reduction that we need until 2030, and is readily available to be installed tomorrow, and without major capex. All the solutions that we have seen in the morning till the last solution was without capex, with minimum capex, and they are available. So, looking at what to be done in design phase, I've split the document to 3 items. The normal service, this is anybody who designs a new plant can do this. Anybody, any process engineer with more than 5-6 years experience and have done 1 or 2 more plants can say that. Second part is the extra mile service, where when you deal with a good consultant, when you deal with a good advisor, you get this second. The last part is what you do to make your plant a future cement plant. And this is what I'm gonna narrate and a bit expand on. Operation guidelines. What we were talking about of AI and operational excellence and whatever, if you planned it while doing the plant through operation guidelines and had a map for making the plant, teaching your people before building the line, this is a way that you don't get into the problems of my operator doesn't want to operate alternative fuel when the plant is there, because you have already signed people, hired people, trained people to run a plant that will run on alternative fuel and will be efficient. So you will not have this problem. Second one is IoT preparation. We always come to the point that we don't have sensors sufficiently. We have sensors that doesn't work. We have sensors that are not available to send the signal. Do it from the beginning. When it's a green field, do it from the beginning. Buy the sensors, which will cost on the plant first capex, nothing. The impact will be nothing. We are talking about, let's say, a European plant, so it's going to be 320 million, 350 million, 280 minimum. This all IoT preparations is less than 2 million. It won't be seen on the budget, but it will make your plant ready to move forward without any blockages on the road. Second one is PIDs and export optimizer and digital maturity. You cannot use AI until you have data. So you build for AI. You build the PIDs, you build the process expert optimizer, you build the digital maturity. So when you go for AI, to buy AI, you have the right history that will allow machine learning in a proper way, and you will have your plant optimized, so the machine will learn the right thing from the beginning. Last but not least is quality process and product optimization, the main blocker. And I'm saying this out of a very long experience with SCMs. The main blocker for SCM is quality of clinker. It's not the availability of the SCM. It's not the buying potential of the market. The market doesn't buy it because the market doesn't, because you don't have sufficient confidence in your clinker quality, so you cannot convince sufficiently that this cement is going to be strong enough. That's why there is a debate on SCMs. In countries where there is no OPC, like Algeria, for example, they don't have this debate. And the same companies that build in Algeria build in Egypt. And their same consultants are okay with the SCM in Algeria because they don't have an alternative, but they are against SEM2 in Egypt because of the color. Same people, same companies. So the idea is, if we cement people focused on the right thing, the easy thing, the direct thing, making our clinker CCS, but the market doesn't need it. No, the market needs it. If you want to go really hard on SCMs, reach 60%, which is already in the standard. We don't need a new standard. The standard is there. But we cannot do it because our clinker is 53. You cannot do 35% and 45% SCMs with clinkers that is 53 and 52. It doesn't work. So you need to do the clinker on 60 on an optimized level with low specific heat consumption to be able to go to SCMs properly. So all our problems can be solved in those 7 parts. If we do it greenfield or we do it for the brownfield. Those 7 points are sufficient for the transition that we need and to do it with the things that we know and then are in control and with minimum capex. And this is what I talked about yesterday on the operational excellence, so I will not repeat the operational phase, but it's good. We didn't have the presentation yesterday, so I was making the circles with my hands. These are the circles I was talking about. So as we said, it's operational excellence, employee engagement, sustainability, GRC, and digital maturity. Those are the building blocks of operational excellence. Finally, I made this slide just for a summary, for everything that can be added to our 7 plants to actually make it decarbonized, futuristic, and you wouldn't see, and I actually put them in families to make it easier. It's very similar to what you have done, Matthias. I'm much better on graphics only, but
graphics is good.
So traditional levers. We have thermal energy efficiency, electrical energy efficiency, clinker quality. Those are the basic. Takes you to product portfolio, alternative fuels, and alternative raw materials. You cannot do the bottom 3 if you don't do the upper 3. Then this takes you to advanced levers, which is added projects on the cement plant to upgrade it, uplift it, waste heat recovery, clean energy, belite cement, calcined clay, activated cementitious material, alternative building material. All those 5 advanced levers, you have seen solutions to it today in the morning. All those. So they are available and they are not at high capex. On top of them, digital levers. Whatever digital levers you talk, it's end-to-end digital maturity. And you have also seen solutions to this part in the first part of the day. Last but not least are the high investment levers, which I'm not against. I'm not saying that they are wrong or bad or inefficient or unproven solutions. I'm just saying that they are derailing the decarbonization approach. Because they are high capex, because the results are not yet seen, because we have so many questions on how they can be made and what are their measures and what are their calculations and what is the area needed for them, because we don't know all of this, it's derailing the move towards decarbonization. So keep it in mind, keep it on our radar, but let's do it when they are possibly to be done. When we can do a conference where we have continuous papers of proven solutions of these, let's implement them. Since then, let's do all the rest. So oxy-fuel, CCUS, electrification, hydrogen fuel are things that are great, but are yet to come. Let's worry with what we can implement and let RD for R&D.
Before you sit down.
Oh, I get afraid when you do that.
No, but everything was emphasized yesterday morning about the urgency.
Yes.
What is your message about urgency? You know, you might say, let's have another conference in a year's time. That's a year, a critical year, another critical year. How can you maintain momentum to keep this going rather than people dispersing and sort of thinking, well, we got there, we did a great job in Dubai, but actually let's relax a little bit now?
Should I?
Yeah, go ahead.
Yeah, okay. With WCA, the plan is to get as much companies committed or actually connected to this roadmap and to have continuous forums, continuous awareness, online connections, exchanging ideas, exchanging actions, making a dashboard.
How do they sign up?
Just being a member of WCA is sufficient for sign up. We will do the rest of the work. We will, as we did to bring everyone here trying to connect this idea, we'll do the same to bring them on the same platform and trying to connect these ideas. And actions actually must have started yesterday. We are really, really too late. Really too late. The things I'm talking about, traditional levers, digital levers, advanced levers, those are things that should have been done 2005 forward. I'm talking about things that were in the WBCSD. I'm talking about things that was announced in 2002.
Can I make an addition to that, Nick?
It's an accelerator.
Too late.
It might be too late.
Can I make an addition?
Can I also, if I may, just Matthias?
Can you go back? Yes, thank you.
Let me ask though, who should be here, who is not here, who needs to be invited?
Governments and banks and consultants for development. But the problem is, and this is also another angle, we also with WCA and with other partners, I don't see if they are in the room or not, Decarbon, we are having the event that will connect those parts of the cycle in COP27 in November in Sharm el-Sheikh, where we are going to have mines, cement industry, concrete, building, steel, banks, and construction, and of course because it's COP, so we have the UN and the IMF and the government in the same place. This is where we try to connect the remaining of the value chain, because this is my point of view that cement to be able to actually act its right, it has to be seen as an integral part of this value chain. I was talking, you have seen the CMAX paper. Their problem is they make green product, but they cannot sell it because the construction is not taking it. The point is, you cannot do any of these without the cement. So cement should be driving, not following. But we are moving so slow, and we are doing much less, and we used even not to talk about what to do for some years. So we are not in rightfully positioned on where we should be on the value chain. And this is what we are trying to fix with WCA and bring cement to its rightful place in the value chain. Actually, it's not in the best benefit of cement industry alone, it's in the best benefit of the climate action, which we need to act immediately on.
Because in 6 weeks you'll be in Sharm el-Sheikh, and I just repeat what Emir said yesterday. We have to be honest. As an industry, we have not done much for climate change. We have to do our job. We have not done our job so far. That's a big message.
If I may to comment, the problem is we don't say enough on what we do. That's one thing. So there is an awareness issue of what we do. Two is we don't do things collectively. We might be the only industry in the world that doesn't have a strong voice to represent properly and continuously over the time. We just have the associations that are in place started 2016, the oldest one.
Ian.
We never had the proper voice. And if you looked at what, I've worked in conglomerates, I've worked in Lafarge and Holcim, and inside there is a lot being done. The material that we talk about now, in some places that is ergonomical and green, it was developed in Lafarge Lyon maybe 8 years ago. We have done that, but we did not properly announce it. We did not make it a trend because it's within the conglomerate. There is no knowledge sharing outside of the group. We are not allowed to share that science with others. It's a property of the group. We cannot give it outside. So it's happening. There is work that's being done, but if you looked at, and this is why one of the missions of WCA, and I think Ian
would like to say
comment on
something.
that. Yes,
Yeah,
of course.
exactly.
Yes.
Yeah.